Hi. In this lesson, we're going to be working with how to understand functions. Now, before we get started, we're first going to go over a few vocab words that are going to make us more successful in this lesson. The first vocab word you want to write down, you want to understand is the word independent variable. Independent variable is always going to be your input. Now, remember, last section when we worked on domain and range, what was the input? It was domain. So independent is going to be the same exact thing as domain. It's going to usually be the X variable, which is your input. So what I would want you to do in this lesson is when you see independent variable, always remember that it's going to be the input, but it's usually going to be the X, all depending on obviously the problem. Next vocab word we're going to have to understand is dependent variable. Dependent variable is going to be the output. Think about last lesson. What was the output? It was a range, and range had what letter? It was usually the Y. So for dependent, you're going to remember usually the Y. Now, remember the word independent. Independent means that it stands alone. You only have to focus on itself. It does not depend on anybody else. So independent is usually going to be the values that you plug into an equation. That's the X. Now the values that you get out of it, that's usually going to be your Y, which you know is your dependent. Think of it as graphing. When you graph a coordinate, you always have to go left and right first on the X axis, and then you do the Y. Because Y, X is independent, you can travel on the X, and then Y is dependent on however you move X. You always do X before Y. So X is always independent and Y is always dependent. Dependent on who? Dependent on X. Next, you're going to have function notation. Now, this was the most important one because if the function is given X as the input and Y as the output, then what you're going to read the equation as is F parentheses X. Every time that you see the word parentheses, you're going to know those parentheses as the word of. So, for example, when you read F of X, that's really going to read F of X. Now take a look at the examples on the left. You're going to notice there's three different ones you have. Look at the first function. It says f of x. What about the second one? G of x. The third one's going to be h of x. So always remember that when you have f of x, g of x, h of x, that's always going to be your function notation. Now notice something. In function notation, in the definition, didn't we see y as a dependent? But look at all of those three equations. Where's the y? Technically there, but what you have to memorize is every time that you see f of x, g of x, h of x, you're always going to know this letter as y. So if you see f of x, what letter is it? Y. G of x, what letter is it? Y. H of x, whatever of x is always going to represent the letter y. And the last one, well, what about my actual equation? That's called the function rule. The rule is usually whatever is on the opposite side of the equal sign. So for the first example, f of x equals 3x plus 5, that's going to be the expression that we're going to use in order to solve the input and the output. So every time that I want to find a letter or a number, I'm going to plug in any x value into 3x plus 5, and I can get my y value out of it. Okay, so think about it. I plug it into the x, I get a y out of it. That's called input and output. Input is your independent variable, output is your dependent variable. Okay, so independent is what letter? It's x. Dependent is what letter? Is y. Function notation is with a reading of f of x, g of x, h of x, whatever of x, and what letters it always going to denote? It's going to be y. And the last one, what is a function rule? The function rule is just the expression you see on the other side, which is going to be pretty much what we're supposed to do. You ready to begin? Let's get started. So the first example, they're asking us to list the independent and dependent variables. Now remember, this is all vocab. So if you remember what independent and dependent variables are, you're going to be able to answer this question almost every single time. So we're going to ask ourselves, what are independent variables? It's what letter? Independent is the X, and dependent represents the what? The Y. So when they ask us to list it, what we're going to do is we're going to answer this in a set. Now remember, a set has these curly brackets on the side. And because we're listing independent, I'm going to put an I. And I'm going to just pretty much ask myself, what are all my X variables? My X is 2, 5, and 6. I'm going to always put it in alphabetical order or numerical order from least to greatest and make sure you don't repeat any of the numbers. So in this case, it's going to already be in order. So my answer is 2, 5, and 6. Close the curly bracket, and that's my set. So now when we ask ourselves what is dependent, dependent is going to represent the D. I'm going to change colors, and dependent is always the what variable? The Y. So look at all the Y coordinates. I have 6, I have -1, and I have 3. And then open the set. and make sure you put it in numerical order. So it's going to be -1, 3, and 6. Close the set, and that's my answer. So always remember, independent is always going to be the X, and dependent is always going to represent the Y. So now we're going to look at example B. If you think you're ready, try it on your own. Pause the video, press play, and I'll be here to answer the question. But if not, look at this example. This example is written as a mapping question. And if it's a mapping question, we have to always remember, let's list them as coordinates because it's going to help us out. So the first thing is we have to ask ourselves, what is going to go with -3? -3 is going to go with 13. 4 is going to go with what number? 4 is going to go with 1. 7 is going to go with what number? 6. And 8 is going to go with what number? 6 as well. So now that we have these numbers, you have to remember 2 is not part of it. So we would never be able to list this as an answer because it never belonged to an actual coordinate. But we're going to go ahead and list our independent. We said independence, what letter again? Independence, the X. So I'm going to open up my set. I'm going to put all the X values from order from least to greatest and not repeat the numbers. So -3, 4, 7, 8. And then I'm going to ask myself, what are my dependent variables? Dependent are all the Y's, but notice that technically I have 2 Y's that are the same, 6. So am I going to list them twice? I'm not. So I'm going to put them from least to greatest. I'm going to open the set. It's going to be 1, 6, 13. And that's it. I'm done. That's how you list independent dependent variables. Remember, independent is the X, dependent is the Y, and you list it as usually a set. Okay? So now we get to example 2, and this is pretty much the most important topic of our lesson. How do we actually work with functions? Remember, functions are, has a function notation, f of x, g of x, h of x, and then the opposite side is going to have a rule. That's the expression that we're going to use to be able to evaluate. Okay, so the first example says if f of x equals 3x minus 2, what do we always know f of x to be? F of x is always going to be the y. And then it says then find f of x. Well, so what do they really want me to find? They want me to find the y. When x is equal to 0 and x is equal to 3. So they want you to find the y when x equals 0, x equals 3. Please remember that x equals 0, x equals 3 are 2 individual problems, okay? They're going to have 2 different answers. So now I have to ask myself and think about it. If I know that x is equal to 0, how do I find the y? What are you thinking? I find the y by substituting that 0 into my expression or my equation. So what am I going to do? I'm going to take this x equals 0 and I'm going to plug it into the x that's my equation because that's the rule. That's what I'm supposed to follow. But how do we plug it in? This is what we do. Since we want to write it in function notation, I'm going to first start off by writing it as f parentheses 0. Notice that I plugged 0 and replaced for the x because that is the x value, right? And I'm trying to get the y. So when I plug in 0, what am I going to get as my y? That's pretty much how you read it. When I plug in 0 into f, what's my y? So I'm going to plug it in. I'm going to get 3 parentheses 0. Make sure every time that you plug in any number that you ever use in an expression or equation, make sure you use parentheses because it's going to matter when we do order of operations. So I'm going to work this out. 3 times 0 is 0. 0 minus 2 is equal to -2. That's my answer, but how do we write this? I'm going to write this as f of 0. Why? Because when I plugged in 0 into f, what was my y? It was -2. And if I wanted to write it as a coordinate, I know that x represents a 0, and what was a y represent? -2. And these are 2 different ways of writing the first answer. Okay? So every time that they give you the function, they're going to more than likely give you an x, you plug it back into the equation, and then you solve for y. And that's how we do the first part. So let's do the second part. So for the second part, I'm going to ask myself the same exact question. I'm going to go ahead and ask myself, I have to plug in 3. So if I have to plug in 3, what am I going to do? How do I plug in 3? What are we thinking? Do you think you have an idea? We're going to plug in 3 by plugging into the main operation. So what does this look like? It's going to be this. It's going to be f of 3. What does this represent? That means I'm plugging 3 into my f, and it's going to be 3 times 3 minus 2. 3 times 3 is 9. 9 minus 2 is equal to 7. So how do I write my final answer? I write my final answer like this. When I plugged in 3 into f, I got 7. So if I were to write that as a coordinate, what would the coordinate be? It would be 3 comma 7. And this would represent 3 different ways of writing your answer. of 3 comma 7. How was that one? Was that okay? Okay. If you feel you're ready, try B. B's a little bit more complicated because you see a square, but at the end of the day, it's the same exact problem. So for B, now they gave me the function g parentheses x, which reads as what? G of x. So I'm going to plug in every value that I get for x into it. So remember, g is the same thing. So I just want to write this out. G is the same thing as y. And when it says find g of x, really all they're asking you are find the y's. Just find the y's. So they give me two values again, x equals 0 and x equals 3. These are two individual problems for this question, okay? So when I plug in x equals 0, how do I plug that in? I'm going to plug in 0 into my x, which is right here. But what's the proper notation of writing it? I got to write it in function notation. So what am I going to do? I'm going to put g of 0, which what does this represent? When I plug in 0 into g, what's my y? So I'm going to plug it in, but remember, every time that we plug in, we have to use parentheses. So 0 squared plus 1. Hopefully you understand 0 squared is the same thing as 0 times 0. 0 times 0 is 0. 0 plus 1 is what? Is going to be 1. So that's my answer. So how do I write my final answer? Technically, my answer is 1. But if you wanted to write it in function notation, it would be g of 0, which means that when I plug in 0 into g, what was my y? I got 1. If you want to write it as a coordinate, it would be 0, comma 1. And these would be my two answers for the first one. So what about the second one? Let's plug in 3. I'm going to do the same thing. I'm going to plug in g of 3. And it's going to be parentheses 3 squared plus 1. I'm going to work this out. 3 squared is what? 3 times 3. 3 times 3 is 9. Plus 1. 9 plus 1 is 10. So that means that my answer is 10. My y is 10. But how do I write it in function notation? It's going to be g of 3 is equal to 10. And if I wanted to write it as a coordinate, it would be 3, which is the x, 10, which is the y. And that would be my final answer. That's it. So yes, it represents a little bit more algebra because we're actually substituting these variables into the equations to get values, but all we're doing is just simple order of operations. Okay. So if you feel that was okay, let's try the second one. You're going to notice that some of the x's are negative. It's okay. I just want to see if we're able to do the negatives. But if you feel like you're good with these, pause the video, start the first one, and then play it and see if we get it right. So for the first problem, I'm going to plug in -1 and 2, but I'm going to read the example first. It says find f of x. What is f of x known as? It's known as y. Then it says then find y. So they're very specific. Hey, find y. Okay, I'll find it, but I need the x. What's the x? X is -1 and 2. So I'm going to go ahead and I'm going to plug it in. This is what I'm going to get. I'm going to get f of -1. Remember, I want to write it in function notation. So it's 5 times -1 plus 2. Now, when I work this out, that's going to give me -5 plus 2. And -5 plus 2, I hope you agree, is -3. That's my answer. So my answer is going to be f of -1 is equal to what y value? -3. And if I wanted to write as a coordinate, remember, -1 is the x, and -3 is the y. And that's what would be my final answer. Or just simply -3, depending on what you see. So for the next one, I'm going to plug in x equals 2 into my equation. So how do I write it again? It's going to be f of 2. I'm going to plug it in 5 times 2 plus 2. Let's work this out. 5 times 2 is what? 10. Plus 2 is equal to 12. So my answer is 12, but if I were to write it in function notation, it's going to be f of 2 is equal to 12. And if I wanted to write it as a coordinate, it's going to be 2 parentheses 12. Those parentheses, and these would be the different ways I can write my answer as a function notation or as a coordinate. Okay? Hopefully you got that right. If you did, awesome job. Now, B. B is actually a little bit more complicated because the exponent and what we're going to be plugging in. But let's read it first. It says if h of x, so now my function is called h, different letters means the same thing, it's all y, equals 3x squared plus 1. 3x squared plus 1 is the rule. It says then find h of x, but we're not going to fall for it. H of x is also known as what letter? It's known as y. So all they're asking us is to find the y. But if you want me to find the y, you have to give me the what? You have to give me the x. So I'm going to plug it in, and this is what I'm going to get. I'm going to get h of -1 is equal to 3 parentheses -1 squared plus 1. Now, this is the part that you have to be super careful with. You can't do 3 times -1 first. Order of operations says you have to always do parentheses and exponents. So I have to do -1 squared. Remember, -1 squared is -1 times -1, which is 1. So really, this is just going to become 3 times 1 plus 1. And if you were to work this out, 3 times 1 is 3 plus 1, you're going to get 4 as your answer. So what does that mean? That means when I plug in -1 into my function h, I got 4 as my answer. So if I wanted to write as a coordinate, -1 is the x, which I plugged in, and I got the y, which is what? 4. And that was my final answer for this one. So remember, whenever you plug in a negative number or a positive number, you have to use parentheses. Parentheses matter because in this case, the -1 actually disappeared to make it a positive one. You got to be super careful with this one. All right, next example. They want me to plug in x equals 2. Okay, same thing. It's my function h. So it's going to be h of 2 is equal to 3 parentheses 2 squared plus 1. Now remember, don't do 3 times 2. You got to do parentheses and exponents first. So 2 squared is the same as 2 times 2, which is 4. So this is going to become 3 times 4 plus 1, which if you do that, 3 times 4 is 12. 12 plus 1 is what? 13. So I'm going to get 13 as my answer. That's my y. But how do I write it in function notation? It's going to be h of 2 is equal to 13. Or if I wanted to write as a coordinate, it would be 2 comma 13. And that would be my final answer. So in this time, I just put 13 on the bottom just because I was running out of space. But these are the different ways you could express your answer and still be right. Okay? So remember, function notation could be any letter. It's just the letter of what the function's called. And you'll learn that later on when we're working with different functions. It could be f, g, h, whatever you want. But at the end of the day, it represents what letter? The y. Okay. So now it gets interesting. We already solved for y, but what happens now if we go backwards? What happens if they want us to find the x? Well, what is the question going to look like? Well, notice in part A, it says if f of x equals 2x plus 2, what is f of x also known as? It's also known as y. Always remember that. And what's the rule? 2x plus 2. Notice the x and notice the y. It says find x. Okay, I found it. They want me to find x, but if they want me to find x, that means they have to give me the what? The opposite letter, which is the y. They gave me they gave me 2 letters. They gave me y is equal to 4, and they gave me y is equal to 6. So remember, 2 different problems. So what do? Well, this is the part where I like to put y equals 2x plus 2. Because if I do that, I now know that the value of y should go on the left-hand side. So now that I know y is equal to 4, I'm going to plug in the 4 into the y. So what does that look like? It looks like this. 4 equals 2x plus 2. Now notice something. This is an order of operations. We're solving for x. Didn't we do that in past chapters? Chapters 1 and 2 when we solved for a variable as well as an inequality. You're just going to do opposite rules, inverses. So now what are we going to do? Let's isolate x by subtracting 2 to both sides. 4 minus 2 is 2 equals 2x. Divide by 2, divide by 2. I get 1 is equal to x, and that's my x. So if I wanted to write it as a coordinate again, it could be 1 comma 4. If I wanted to write it as function notation, it could be f of 1 equals 4. Or just x equals 1, depending on what you see. And these are the 3 answers that you're going to have in this problem. So notice that whenever they give you the y, unfortunately, you do have to do a little bit of algebra. Not order of operations anymore. You have to now solve for that variable. Let's try the last one on this slide. What is y equal to 6? Where are we going to plug this into? We're going to substitute this into the y. So it's going to be 6 is equal to 2x plus 2. I'm going to solve for it. So what am I going to do? I'm going to subtract 2 to both sides. 6 minus 2 is 4 equals 2x. Let's divide both sides by what number? By 2. And I'm going to get 2 is equal to x. That's awesome because if I know 2 is equal to x, that's my answer. But if I want to write in function notation, then it would be f of 2, which is the x, is equal to the y, which was 6. If I want to write as a coordinate, it would be 2 comma 6. And these are the different ways that you can express your answer and all be the same. So if you struggle with chapter 1 or chapter 2, unfortunately, this slide is going to be a little bit more troublesome because you have to remember opposites. How do I get x alone? How do I get my letters alone? By doing the inverse, which is the opposites. So now we move on to the last few slides. We worked with function. We worked with the rules. What about if they give it to us as a table? How do we solve this? So for the first one, it says if f of x defined, f of x is known as what letter? F of x is known as y. So every time that I see f of x, I'm going to write a y because I know that's my y column. It says, is defined below, then determine the following values. I'm going to look at the value. It says f of 3. F of 3. What does that mean? F of 3. Well, remember, 3 is in place of what letter? 3 is in place of the x. So they're telling you, hey, this is the x right here. But whenever you see f of, what is that letter known as? The y. So what do they want? They want the y. How do I read this again? When I plug in 3 into f, what's my y? Look for 3, and I hope you agree, it's right here. 3 comma 9. So when I plug in 3, what's my y? My y is 9, and that's my answer. Let's try the next one. F of 4. 4 represents what letter? 4 represents the x. I'm plugging 4 into what equation? The f. So when I plug in 4 into f, what's my y? What do you notice? 4 comma 12. So what's my answer? 12. Again, every time you see f, they want you to find the y because f is y. They give you the x so that you can find the y. Okay. 3, if f of x equals 6, notice how they wrote that. F of x, then x equals, so they want x. So now they want you to work backwards. So what I'm going to first do is let's erase this right here so that we can start off with a clean table. But what is f of x also known as? Y. So they're telling you, hey, y is equal to 6. Okay. So look for y equals 6 and then find its partner, which is the x. Y equals 6 is right here. Its partner is 2. So what's my answer? X equals 2. Last one. If f of x equals 12, again, y equals 12. Look for 12 on the y. I found it. What's the partner? What's the x value? 4. And that's my answer. So this slide tends to be a little bit more troublesome for students because of the fact that you have to go forwards and backwards. You have to always remember the notations. Function notation, when you see f of x, that represents y. If you see a number in for x, that means they gave you the x, they're asking for the y. Okay? So now we're going to try the same exact slide with different values, but I want you to try this one on your own. Pause the video, then when you're ready, press play and then see if we got them right. So in this problem, it says if f of x is defined below, f of x is known as what letter? Y. So every time I see f of x, I'm going to write a y on top just so I can help myself out. It says determine the following values. F of 2. Remember, f of 2, 2 represents the x because it's in the same spot. I'm plugging 2 into f, and what's my y? When I plug in 2 into x, my y is negative 2, so the first one should have been negative 2. Second one, f of 4. I'm going to plug in 4 into the f. That's right here. I get 4 comma negative 6. So what's my answer? The y, which is negative 6. Now I'm going to move on to the next one, but notice the notation is just a little bit different. Now they want the x value. Okay, so what does that mean? They have to give me the y. How do I know they gave me the y? It says y equals negative 10. So I know that they gave me the y. So I'm going to look for negative 10 on the y and then ask myself, what is the x? What is the partner? 6 comma negative 10. That means my answer is going to be 6. That's the x. And then last one, if f of x equals negative 6, that's y equals negative 6. Then x equals, I'm going to look for negative 6 on the y. That's right here. So then what is the x value that goes with it? 4. That's my answer. Now, sounds simple once you get used to it, but you have to be great at the notation. So again, practice it. Make sure you study. Make sure you know it. Make sure every time you see f of x, g of x, h of x, you always write y. And then all about the notation. And then last problem of this lesson, they want us to find an incomplete table. They want us to fill it in. So in this example, it says if the following table represents y equals x minus 4, wait a minute, what does this mean? Y equals x minus 4? They gave me a rule. Usually when they give me a rule, I have to substitute things in there to solve for it. Okay, just think about that when you see it. It says then find the missing value. Okay, look at the missing values. They gave you 2 x's and they gave you 2 y's. 5, 7. Now, if you thought you didn't have, if you didn't think properly, you probably would have thought, oh, let's just finish the pattern 5, 7, 9, 11, right? Because it's counting by twos. But unfortunately, we don't know. Because how do you know there wasn't a gap skipped? We don't know. That's why they give us the rule. So that we have to ask ourselves, if they give me 5 on the x, if they give me 5 on the x, how do I find the y? Well, remember, they gave me an expression. So what you're going to do is you're going to take the x value and you're going to plug it in into the x. So what does that mean? It's going to be y equals 5 minus 4, which don't overthink it. What's 5 minus 4? It's 1. And that's my answer, 5 comma 1. That's the power of a function. They're able to give you a rule that you're able to plug in to find the missing value. So again, they gave me the x equals 7, so I'm going to plug it in. It's going to be y equals, I'm going to plug in 7 for the x because it's x. 7 minus 4 is what? Is 3. So it's going to be 1 comma 3. Now we're going to move on to the next one, but notice they don't have an x now, they give me a y. So you have to ask yourself, how do you solve this? What do we do when they give me a y? I'm going to plug it into where? I'm going to substitute into where? I'm going to substitute into y. So how do I solve this? It's going to be 24 equals x minus 4. Notice that the x is missing because that's what we're solving for. We're finding that missing x. So I'm going to solve it. Whenever I solve for x, what do? I have to do inverses, opposite. What's next to x and do the opposite? There's a minus 4 next to it, so opposite will be plus 4. So I'm going to go ahead, I'm going to plus 4, and I'm going to get 28 is equal to x. And that's my missing x value for the third one. Now the last one, I'm going to come to the side. They give me y is equal to 30. That's okay. I'm going to substitute 30 into where? The y. And it's going to be 30 is equal to x minus 4. I'm going to add 4. Remember, opposite rules. And then it's going to be 30 plus 4, which is 34. That's equal to x. So I know my missing value is 34. That's it. So remember, in this lesson, when they give you a function rule, it's going to allow you to find the x or solve for the, it's going to allow you to find the y or solve for an x. It all depends on what they're given, but they're going to always give you one of them. Remember that we learned vocab words such as independent, dependent. Remember, independent is the x, dependent is the y, and we learned rules like function, notation, and the rule. Okay, so hopefully this was a great lesson. Thank you for watching, and I'll catch you next time.